If you want to get the benefits of faster render times, you can use shadow map shadows. However, you will have to adjust some of the parameters in order to get good results. So right now I've got the standard default ray trace shadows on my light. So the first thing I'll do is I'll choose shadow map, and let's give that a shot. I'll go ahead and render that and see what we get. And the curious thing is that I get no shadows suddenly. And this is something that might bite you. What you'll need to do sometimes with shadow maps is go into the shadow map parameters and play around with some of these things. Specifically in this case, I'm having an issue with the bias parameter. Bias is the distance of the shadow image away from the shadow receiving surface. It's very non-physical. It's not like the real world at all. If I reduce the bias value, it's going to move the shadow relative to the surface. So with a value of 0.1, you'll see we're getting a partial shadow and a partial garbage. Well, you could play around with this bias factor all day long, but it's actually just quicker and easier to flip this switch that says absolute map bias. And that'll usually cure the disease. All right, so far so good. So we've got a shadow map, and by the way, I do have Final Gather disabled so that we can see the edge of the shadow very clearly. So if you look closely, you'll see that there's some aliasing here. There's some jagged edges, and we need to cope with that somehow. There are two parameters that deal with the softness of a shadow map. You've got the size, which is the resolution in pixels, and you've got the sample range, which is a blur factor that's applied. So to see this most dramatically, I'm going to reduce the size down to something very low. You would never take it down this low, but just to show you what the deal is. So here we go. Really bad aliasing on my shadow edge because there's just not enough resolution. So I could increase the size. If I wanted really clear, sharp shadows, I can increase the size to maybe like 1024 or 2048. And for efficiency's sake, you should use power of 2 values. In other words, 512, 1024, 2048. But just watch out, because if you go up beyond about 4000, your memory usage is going to be pretty extreme. The render times will still be fast, but you'll eat through a lot of memory if you've got a high resolution or size. So that's how you would achieve a sharp edge to a shadow map. If I wanted a blurry edge, I could reduce this size down to something like 512, which was the default, and I could increase the sample range, which is just simply a Gaussian blur applied onto the pixels that constitute the shadow map. So higher values mean more blur. So if I set this to something like 20, which is a lot of blur, we should be able to see some softness to the shadow here. And I can exaggerate that by further reducing the resolution. So a low resolution and a high sample range will get you a softer shadow. However, it's not physically accurate, and it doesn't respect transparency. If you need transparency in your shadow maps, then you'll need to use the mental ray shadow map. And it works pretty much the same as the standard shadow map. So those are the parameters to play with. I recommend if you're using mental ray, most of the time you're going to want to use the ray trace shadows, except if you've got scenes with a large number of lights.